Vector pathways are probably the most problem-solving types of questions that you get in vectors. You either love these or you hate these. So as long as you think it through, you should be all right. You're far more likely to be asked about a 3D vector pathway at higher. So looking at this first example, which is a 2D vector, they're giving you quite a lot of information, but they want us to express QT in terms of AB. So that's what vector pathways is all about. It's just expressing things in different ways. So they want us to get from the vector Q, which is this point here, down to the vector T. Now, given the fact that we don't know what letter or what small letter that is, we have to use an alternate journey. So we have to use a vector pathway. So look at what you know about this. We know that if we went from Q to P, we would be travelling backwards on B. So start off for Q to T. First thing we're going to do is travel backwards on B, which would be negative B. We could then go from P down to S. So to get from P to S, we're travelling along A. So we're adding on A. And then this is where this piece of information over here comes in handy. So there's a reason that they're telling us that. We just need to figure out what it is. So what they're saying is that R to T, so this distance here, is in the ratio of 1 to 2 with this distance here. So they're saying that S to T is twice as long as T to R. Now, the reason that that must be important is because, remember, in vector journeys, parallel lines are going to be the same thing. So if we have a parallelogram, we know that S to R is actually just going to be B, right? So it's just the exact same as this line up here. However, we don't want to go from S to R. We want to go from S to T. So in other words, we want to go 2/3 of the way to R. So we want to add on 2/3 of B. So we can now simplify this. So we've got an A, we've got 2/3 of B, and we're taking away a B, which would give us minus 1/3 B. And that's going to be our final answer. Moving on to the 3D example. So they want us to express P to R in terms of F, G and H. So we're starting off at P and we want to travel to R. So we're going from P to R in that direction. So you need to look for the vectors that you know and then you can travel along them. So I'm going to start off, I'm going to come down to T and that is going to be negative H because I'm going backwards over H. Still trying to get to R. I could go either way, so I could go along to Q, I could go along to S. I'm going to go along to S, and that's going to be plus F. So I'm moving in the right direction towards S. I'm then going to have to go back to get to R. Now that one, it hasn't got a letter next to it, but as I said in the last example, if you know that these two lines are parallel, which they must be because it's a square-based pyramid, this line here must also be G, so we're moving in the positive direction of G. Now, just so that I've not got any negatives at the start of my vector journey, I'm just going to rewrite this as F plus G minus H, and that's my final answer.